Today, we're going to crack open a document that you almost never get to see. This is an internal maintenance manual from ZPEC, a major player in the oil and gas world. We're going to dive into the playbook they use to stop disasters before they can even start, in some of the most dangerous workplaces on Earth. So, just for a second, picture an oil rig. It's this incredibly complex machine, costs hundreds of millions of dollars, and it's surrounded by highly flammable stuff, often miles from land. How in the world do you stop one tiny bolt from failing and setting off a total catastrophe? Well, the answer definitely isn't just crossing your fingers and hoping for the best. It's all about a systematic, proactive strategy. It's a plan that's designed from the ground up to master risk and make sure every single piece of that machine works exactly like it's supposed to, every single time. All right, so to really get how they pull this off, we're going to walk through their playbook. We'll start with the high-stakes world they're in, then get into their proactive solution, see how they choose the right approach for the right part, look at the amazing cycle they use to constantly get better, and finally, meet the people who make it all work. So, first things first, let's just absorb the reality of where they're operating. This is a world where mistakes aren't really an option. The consequences are just way too severe. I mean, what does failure actually look like out here? It's not just a broken part. No, it's a domino effect. A single failure can lead to horrific injuries for the crew. It can cause devastating environmental spills. It can destroy millions of dollars in equipment, absolutely shatter a company's reputation, and bring operations to a grinding halt, costing a fortune for every single minute of downtime. Okay, so how on earth do you manage that kind of risk? You build a system. A system designed to get ahead of failure before it even has a chance to happen. You create a comprehensive maintenance strategy. And what I find really fascinating here is this quote, pulled directly from the manual. See, the goal isn't just fix stuff when it breaks. It's about balancing cost, reliability, business goals, and what they call HSE, that's health, safety, and environment. It's this complete 360-degree view of what success actually looks like. You know, the best way to think about this whole thing is like a health plan for a giant machine. You don't just wait for it to have a heart attack and then rush it to the emergency room. No, you schedule regular checkups, you monitor its vital signs, and you try to predict problems before they ever become serious. It's all about prevention and prediction, not just reaction. But here's the thing. You can't treat every single nut and bolt with the same level of obsessive care. That would be crazy expensive and wildly inefficient. So the strategy has to be smart. It has to know where to focus its energy. And the way they do that is by identifying what they call critical equipment. It really all comes down to one simple question. If this part breaks, what happens? And if the answer involves a serious risk to people, to the environment, or to the entire operation, well, then you've got yourself a piece of critical equipment. And this slide just illustrates the two philosophies perfectly. On one hand, for something non-critical, like, say, a light bulb in a closet, you can use what's called a run-to-failure approach. It breaks, you screw in a new one. No big deal. But for anything critical, and I mean anything, like a blowout preventer, that is absolutely 100% unacceptable. That must get preventative maintenance. So within this larger strategy, they have this whole toolbox of methods to choose from. There's predictive stuff, like analyzing vibrations or testing oil samples to catch problems early. There's the classic preventive maintenance, where you replace parts on a schedule before they have a chance to wear out. And like we just saw, there's the strategic use of breakdown maintenance, but only for the really low-risk items. But here's the real genius behind this whole thing. In a world this complex, a static plan, a set-it-and-forget-it kind of checklist, is a recipe for disaster. Things are always changing, so the most powerful part of this strategy is that it's designed to learn. It's a living, breathing cycle of continuous improvement. And you can see exactly how this cycle builds on itself. It all starts with a regime, which is just the basic set of rules. From there, you plan the work, then you go out and do it, and then, and this is the most important part, you report back on everything that happened. All that data gets funneled into an analysis phase where they look for trends and root causes. And finally, that analysis gets used to improve the original regime. The whole system gets smarter and smarter with every single rotation. So what's the engine that's driving all that analysis? It's a process called Failure Mode Effect Analysis, or FMEA. That sounds complicated, but it's really just a super structured way to brainstorm everything that could possibly go wrong, figure out what the consequences would be, and guess how likely it is to actually happen. It's about systematically thinking through worst-case scenarios so you can stop them. And this is how they visualize all that risk. It's a risk matrix. On one side, you've got the consequence of a failure, from basically negligible all the way to catastrophic. And on the other side, you've got the probability of it happening. So if a failure is both frequent and catastrophic, you see that X up in the corner? That's the red alert zone. That gets the highest possible level of attention. But if something is improbable and the consequence is negligible, it's an L for low risk. This simple tool turns abstract risk into a very concrete plan of action. So what all this analysis drives toward is a fundamental shift in mindset. You're moving from being reactive to being proactive. You're not just running around fixing things that broke yesterday, you're using data to prevent things from breaking tomorrow. But a plan is just a document. A system is just a diagram on a slide. None of this works. None of it without highly qualified, experienced people on the ground making it happen. And I mean, just look at the kind of baseline experience required here. We're talking more than 10 years for an equipment manager, 5 years minimum for mechanics and electricians, and 8 years for a specialized BOP engineer. That's the person in charge of the blowout preventer, probably the most important single piece of safety gear on the entire rig. This is not a place for on-the-job training. The whole system is built on a foundation of deep, hard-won expertise. And it's not even just about individual skill. The manual puts a huge emphasis on structured communication, regular meetings, clear reporting, processes for transferring knowledge from one shift to the next, from the rig to the main office. The entire organization is designed to learn together as a single unit. So, what's the big idea to take away from all this? Preventing catastrophe isn't about some magic bullet or one perfect checklist. It's about a dynamic, living system. It's a continuous loop of planning, doing, analyzing, and improving, and it's all powered by the skill and communication of the people on the front lines. It's an incredibly robust system for an oil rig, for sure. But it kind of makes you wonder, right? What cycles of planning, analyzing, and improving do you already use, maybe without even realizing it, in your own work or even in your personal life? And where could a more structured approach, like this one, help prevent failure before it ever